Okay, hello. So, in the previous video, I showed you how to do an imaginary hypothetical experiment, kind of classification, inspection of 1000 batteries. And as a result, we have four frequencies, and you can determine probability of defective batteries. So there are two outcomes, two types included in this event. So that's domestic and defective plus imported and defective. And the total number is 40 batteries. 40 batteries, 40 smartphones have defective batteries. And then the probability is 40 out of 1000. So it's 4%. The answer is pretty simple. So as I said, once you get to these numbers, calculating probability is not a big problem. It's just because the sample size is 1000 and just check which outcomes are included in that event. That's pretty much it. So that is an easy process. And okay, this is easy, but from now on, we are going to formulate a formula out of it. So the idea is clear, simple, and mathematically, we are going to make formula using mathematical notations. So that is an interesting part. So this is, if you want to see the table, this is the table, and we are interested in defective batteries, the first row, and then you get 4%. Okay, we are going then backward. How did we get 4% from these processes? Okay, let me show you. Let me go the other way from the answer to the underlying objects. Say, we calculated the probability of defective batteries in this way. So 1000 was our choice. 1000 was our choice. Then where did 12 come from? 12 was calculated as 2% of 600, right? We are going the other way. And 28 was calculated as 7% of 400, right? And remember, the reason why we use 2% is because this was the defect rate for domestic batteries, and 7% was the defect rate of imported batteries. Okay, these numbers are, we know where these numbers are from. But then, where 600 and 400 are from, the answer is like this. 600 is 60% of 1000. So 1000 is the whole number, and 60% was used because we knew that 60% of batteries are domestic. So this is the probability of domestic batteries. Similarly, where did we get 400? This was obtained as 40% of 1000. 1000 again is our choice, and 40% is the probability of imported batteries. Okay, then we learned where they are from. 1000 can be cancelled out, right? So 1000 will be cancelled out, numerator and denominator. And then 2%, remember 2% was the conditional probability of defective batteries among domestic ones. 60% was the proportion of domestic batteries. 7% is another conditional probability. 40% is unconditional probability. So after canceling out 1000, we have a formula. Basically, this is how we calculate this unconditional probability. So unconditional probability of F, to calculate this, we need conditional probability and unconditional probability of D. That is our formula. This is how you can understand the formula, and in general form, you get this. Okay? So I'm not saying you need to memorize the formula. Memorizing the formula may help, but pretty much useless in your life. What's more important is to understand how this is derived. So derivation of this formula is pretty intuitive. So I wanted to show you that this how this works. Okay, then you may let me explain a little more. So probability of A, if you are interested in probability of A, you can write it as probability B times conditional probability of A times A given B plus B complement A given B complement. It has an interesting interpretation. You may think it as a weighted average approach. Weighted average. So you are interested in A, but to understand like the chance of probability of A, you divide the whole population into B and B complement and study in one group and calculate probability of A given B group. And on the other group, for the other group, you also calculate probability of A given B complement. And then you have two probabilities of A. Then you have to add them to obtain unconditional probability. But when you combine them, you need to use correct weight. You have to use the weight depending on the proportion of each group. So, for example, think about this like in our earlier example, tuition and salary. You are interested in the overall probability of overall probability of high salary. Then you may study the probability of high salary among high tuition graduates and then low tuition graduates. And then you have to combine them, but when you combine them, you have to adjust the weight depending on the proportion of high tuition school graduates and low tuition school graduates. So this is the weighted average. Weighted average of conditional probabilities can give you the unconditional probability if you choose the weights correctly, right? So this is how you can understand the formula, and you may understand the formula using the diagram tree method. So it's up to you. I'll try to give you different ways to understand that. So now the next question is, given the same results, we would like to calculate probability of domestic batteries among defective ones. You try this. Okay. So let me show you the answer. First, our condition is defective batteries. So that means you erase this. There are only 40 batteries, only 40 defective batteries that satisfy the condition. And out of them, you are interested only in domestic batteries. So 12 batteries out of 40 are domestic batteries. The answer is 30%. 30% are defective batteries. I mean domestic batteries among defective ones. Okay? So then I'm going to do the same thing. We are going to go backward how we got this number, 30%. Let me show you again. So we want this one, so we calculated that in this way, 12 over 12 plus 28. And 12 is from 2% times 600, and 28 is 7% of 400. And you know where these are from. And then again, 600 was calculated as 60% times 1000, and 400 was 40% times 1000. Okay? And then in the end, after you cancel out 1000, you only have those probabilities, complicated probabilities. So we have a formula. this is the formula. By the way, as I said, it doesn't matter which number you choose. I chose 1000 because that is convenient. I knew that it was convenient. But if you choose like 2000, 1 million, it doesn't matter. Anyhow, it will be cancelled out. And it does not, your choice should not remain in the formula. The formula is it's not affected by your choice. So as it should be. And this is the formula, which is known as Bayes rule. It is a very famous rule. Bayes is a name of a statistician a long time ago, and he made up. So following his name, there is a very famous approach called Bayesian approach, which is actually totally different from what I'm teaching. So it's philosophically different. So here we are assuming that probabilities are given, but in the Bayesian approach, they think probabilities are not given. It is unknown. We never know what is the probability, but we only just update. It's a belief. Probability is a belief, and we just update the belief as we observe more data. So it's philosophically different, but still this formula is very famous. How it is about how to convert probability f given d into probability d given f. So flipping the conditional probability is Bayes' rule. So again, this is the rule, formula, very famous formula. But I don't ask you to memorize this. It's memorizing this formula is not desirable. Like, so you don't need to. But another, I will show you how this one is derived. So you can think this as like a result from the classification tree method, but at the same time, you may think it as mathematical derivation. So we want you to calculate probability B given A, and by definition, this is the definition of conditional probability. You may write it this way. Out of probability of A, you calculate probability A and B happen at the same time. And then, using the multiplication rule, general multiplication rule, the intersection probability can be written in this way. This, the numerator, like put it this way, okay? So this equality follows from the definition, and then numerator uses the multiplication rule, general multiplication rule. So already probability B given A is expressed as probability A given B, right? So this is how you flip the conditional probability. And furthermore, the denominator, if you want, denominator can be written in this way using the formula we derived earlier in the previous video. Actually, this video. At the beginning of this video, I showed you how to formulate unconditional probability using conditional probabilities. Okay, so it's a weighted average of probability A given B and A given B complement. So this is Bayes formula. So you may what I just showed you is this is mathematical proof for Bayes rule, but you can just understand it using the visual diagram. That will be more intuitive. Okay. So this is it. So this is the end of this video. So we have one more example to study, and that is also a practice, an example about Bayes rule. So similar setup, different example. Okay. So see you in the next video.